Hey everybody, I'm back, and it's time for that one where we actually learn to read and write the language we've been using for several episodes already. So, Python. What is it? How does it work? Before we get super deep into all of that, I want to just clarify one thing. There's a bunch of things that I'm showing people that if you are a Python user, especially if you're someone who's been using Python for a while, you might be looking at some of the stuff I'm writing, some of the stuff I'm doing, and kind of cringing a little bit. There are a number of ways to optimize Python. There's a number of ways that you should do things, in the sort of the Pythonic way, they call it, that I'm not really doing, that I'm not really following, exactly, because to me, there was a barrier when I first started learning Python. The great thing about Python is you can write it like it's just like language. It's not one of those things where everything has these weird, little syntax. If you look at some other languages, like look at C or like C++.
Oh! I'm okay.
You'll see that Python is a little easier to read, even if you don't know any code. It's just kind of like it looks a little less foreign because it's mostly words, and it's kind of laid out in a way that it's a little friendlier. What I find is that the right way to do things, the best way to do things, the most efficient way to do things in Python is not necessarily the easiest way for a beginner to understand. And so I will quite often go through a process with my add-ons or my scripting processes, I guess. I'll start with like a pseudo code idea where I say, I want to take the cube, scale it up, rotate it around, and do this. And then I can have like a little pseudo list. So I can kind of say, my pseudo code is get cube, scale up by 2, rotate backwards, and then delete face. So I can write that out, and that will tell me logically what I need to do. And then I will kind of translate that into the actual Python code that I need. So if I want to do import bpy to get the cube, I'd say bpy.data.objects, just in case it wasn't already selected. Cube, bpy.context, dot select set true. Let me see, I think that's what it is. Unclick and right. I should probably delete that pseudocode. It doesn't like that. And there we go. So that is okay, we'll undo that. So I've got that, and then we can do the rest of the stuff to work it out. And then usually I'll kind of look at it and go, oh, that's not the most Pythonic way. That's probably not the most efficient way. And then I'll kind of refactor after I've got this. Maybe there's a way to do this in one line. Maybe there's, a couple of different things that we can do. But what I'm showing here is largely not going to be the best, the fastest, most efficient way to do things. What it will be is what I think is the most easy to understand for someone who doesn't already know any of this stuff. So probably, you're going to read this code and you're going to, look up, how do I do this? And someone's going to say, oh, you shouldn't be doing this. You should try X, Y, and Z. And, when you're ready for that, by all means, dive in. Maybe I'll revisit this in the future to kind of go over some more advanced or some better ways to handle things. But for right now, this is all just kind of keeping it as simple as possible and as clear as possible. So we'll look at a couple of different things that Python has in it. So we import, and actually, before we go any further, why is it that when I type import, it's pink? When I type bpy, it's white. When I type cat, it's white. When I type is, it's red. When I type dog, or whatever I want to type, it's white. Let's see, as, from, So a bunch of these are, magic words, keywords that are built into Python. So we always start everything with import bpy because import is a magic word. It's not just, the word import. We're telling Python you need to do something. You need to go and find this Blender Python library and you need to bring it in here so that we can start working with it. Same with from, with is, with as. There's a bunch of them, and you'll probably just get to know which ones they are from reading scripts, from learning, how they work yourself. But every once in a while you might type in something and all of a sudden it turns bright pink and you're going, oh, I guess that's something that Python can do. And like I said, it's a very, very good idea to learn what all of these are, but we're just kind of dipping our toes in and we're taking it one step at a time. So one thing you've seen me use before are comments, and comments are a great way to both document your code and also kind of troubleshoot, because you can take any section that you're not sure about and just get rid of it. So I'll show you how that works. So for a basic example, and like I said, you'll see this in a lot of Blender scripts. One of the first lines will be after import bpy is object equals bpy.context.object, or sometimes you'll see obj. So if you're a beginner, you might not really understand that. So when you're first starting out, great idea is, write your comment to explain the code to yourself as well as to everyone else who may want to come after you. So we're going to use a £, a hashtag, a little tic-tac-toe thing, a little symbol that separates generations by what they choose to refer to it as. And we're going to write a little explanation of what this, the line does. So we're going to say this creates a, what do you call it? Convenience variable called object that is our active object. Okay. So we've got an active object. Code runs. Looks great. So let's say object dot funky dance equals 9001. Okay, now let's run this code.
No, you can't. Don't even try.
Okay, we've got an error. Object has no attribute funky dance. So I made up a totally stupid variable or thing to call it here. But this is a good example of, maybe we've got something here that's just possibly giving us trouble. We're not sure what it is. It says something on, line 6. Let's run that, get that error message again. Oh yeah, here it is down here. Object has no attribute funky dance. So what if we just take this out? Now our code runs again, no errors. So what that symbol is doing is it's saying, hey Python, anything on this same line that comes after this symbol is just a comment. This is just words for the programmer. This is not instructions for the machine. So if you see this symbol, ignore everything else on that line. So we can add another line if we want. If we just start typing on the next line though, you can see it's white. So that means it's going to be code. It's going to be instructions for Python. It's not just a comment. So we have to make sure that we've got that comment there, and then we can write anything we want. And the same goes, even if it's already code, we pop that in, now it's a comment. And I'm in the habit of adding a space. You don't have to. You can just throw that in there. Another handy thing that you can do is, let's say we have, a whole block of code, and you don't want to go through and kind of do the whatever, for everything. So what happens if you want to comment out a big block of code so that you can say, you know what, just don't do this whole thing. I don't want to mess with it. You can select everything, go up to edit. I believe it's edit. Might be text or format. Yeah, toggle comments. So you can see it's control/, so control/, or obviously format, toggle comments. So that's if you have a whole list and you want to just, say ignore all of that stuff. And that's all well and good. But what if you have, what if you want to create an explanation for like a really complicated thing that you're doing up here? Well, you might need more than just one line, or you might get sick of if it's going to be 50 lines. You don't want to start everything. You might forget one of these, and then, you might be in some trouble. So there's another way to do comments in Python, and that is a multi-line comment. So that is going to be starting with 3 apostrophes. Then you can write whatever, however many lines, la-di-da, and then close it with that same thing again. So that's a way that you can, add a more detailed comment. There's a certain documentation structure that wants you to use these, and you'll see it, I believe, in here. Yeah. I guess it's not really in use so much there, but you will see those for other operators. Maybe we can find an example here. What about a modal? No. What about a timer? No. But anyway, that is a multi-line comment, basically, with the 3 apostrophes. And actually, you know what? That brings up another good point, which is, hey, in some of those, they were using double apostrophes, and in some, they were using singles. You can use them for the most part interchangeably. You will eventually probably get into a situation where you have to, say, do this comment or perform this thing where you need a comment inside of a comment, or it'll make sense kind of when you get to it. But that gives you an option. If you need to have 2 different types of quotations, then you have access to them. But if you just need to say, do this, comment this, whatever, you can pretty much use them interchangeably. So we've talked about, kind of how the language works. We haven't really looked at how to do things. So we'll look at another thing that we've kind of seen before and do more of a little explanation or a deep dive. So right now we're going to talk about functions. And functions are things that do things. So it's kind of like an operator. It's like a mini operator. Like a function would be just one part of an operator. And I think I got, a pretty basic one. So we import bpy. Let's define delete. So this is going to be a new function. I know we've got an operator. We've got a bunch of things, a bunch of ways that we can do this. But this is going to be a function. This is going to be a function that deletes whatever object we tell it to delete. So to define a function, that's how we do it. And then we make sure that any code underneath is indented. But we're not quite done with this first line yet, because we've created this function. We've said, okay, we're going to have this thing. It's going to do something. We don't know what it's going to do yet because we haven't written the code. The code's going to go down here. But we know what we're going to call it. We're going to call it delete. We're going to put the 2 little brackets after, which means it's a function. And then we're going to add the little colon to say, okay, and here's what the function is underneath this. But before we leave this, I'm going to pass in an argument. Or I'm not going to pass in. I'm going to say that we're going to need the user to define an argument here. So what are we going to delete? We're going to delete the object. So anytime you call delete, you're going to need to tell it what the object is. So we can just start referring now to object. We don't need to say what the object is, because that's going to be up to the user in this function. That's why we put it up here, because this is something that you can define on your own. So the object, we'll say select it, which we do by select set true. And then we will just perform that old one that we know how to do. bpy.ops.object.delete. Delete. And because it is a function, we got to put the 2 little things there. So now we have a function. So I'm going to click off so that we don't have our selection here. But now this is, a super duper basic function. So anytime we want to call delete, now that we've created it, we just have to pass in the object, and then it'll take whatever we tell it to and perform this function on it. So let's say we want to call it, we say delete, and then we put the 2 brackets in to call the function. So if you're setting it up, you have to put the colon after. If you're just calling it, it doesn't get the colon, and I don't think this will work. Okay, yeah, it doesn't work. So it says, type error, delete missing 1 required positional argument object. So we said, use this function, but we didn't tell it an object to delete, so it's not going to work. So there's a couple of different ways we can do that. We could just say object is bpy.data.objects, and then say the cube, because we know how to do that. So let's see what happens now. Cube's gone. So let's do this in a slightly more Pythonic way, because I don't think it'll like us doing that as much. I mean, not that there's any reason, it's just sometimes you're going to get into something where you'll have a really long line where it's really hard to read, like we were seeing with that resize when we were scaling the X. And if you can make a shorter line, make it a little easier to read, which reminds me we haven't talked about line length, so that'll come in a second. So what we're going to do here is we're going to say object is equal to bpy.data.objects.cube, and then we'll say object equals object, and there it goes. And that actually might be a little confusing for, that probably wasn't the best. So cube is equal to this, and object is equal to cube. Because that gets us into a couple other territories where that'll get us into a little bit of scope, because basically what is happening here is the object inside of this delete function doesn't really have any idea about anything else called object outside of the delete function. So anytime you want to create a variable, if you create it inside that function, unless you return, and that again is getting into more advanced stuff, you are not going to be able to access that outside of that variable, which on the one hand, it's like, okay, well, that's kind of a pain in the butt. On the other hand, it's pretty handy because if you want, you can just copy and paste blocks of code, or you can just, you can use object all over the place because each function isn't going to know what the other function's object is. So that might be a little confusing, but basically, these are all going to work independent of one another. You can create these variables, and they can operate independently of one another inside each function, inside each class, because they're not globally declared. So if I say object equals this, the entire code doesn't necessarily automatically know this. If we want to create our object here and then pass that in as the object here, then we just pass that in as an argument. So that is scope. And kind of along those same lines, we'll talk just briefly about indentation. So the same way that I kind of said, you've got bpy, and bpy is like a container, and it's got inside it ops, and then, we look inside ops, and ops has object, and object has delete. The same thing is happening really in our code here. So we've got this baseline here. So the far left side where we start typing, if we start a brand new line, we start typing here. And that was some truly atrocious typing. But basically that sets our initial level. And then when we do something like we create a function, the way that we say, everything underneath here is part of this, and everything underneath here is not, is by using indentation. So we've got the function, then we indent a line. Anything that's indented now is inside this function. It's considered a part of this function. Anything that goes back to that line where we have def, where we have import bpy, is considered outside of that function. And let's look at an example of another layer of indentation through some of the actual, like the how we would code something. So I'm showing you everything now, like, do this operator, do this, adjust this. But that's not really the strength of code. The strength of code is saying, do this under these conditions. Do this when this is happening, and don't do this when this other thing is happening. Okay, so let's think of a quick little example. Let's add something simple in here. So we will say if, so this is one of the first ways, one of the easiest ways that we can get our heads around when we should do something, when we should not do something. So let's say if the object's name is equal to cube, then we will delete it and print cube deleted. Wonderful. Or else, else if not object.name equals cube, print that's no, oops. Yeah, oh, what a perfect example to use our double quotes. Okay, so here I want to use that's as my little string to type to the user. But the problem is, when I put that in, it's messing up my code now because I've got an apostrophe in there. So if we want to remedy this, we don't really have to change anything. We just use the other quotes and we say, you know what? That quote is part of our string. That's part of our quote. So don't try and turn anything else down here into code, because this, or into a comment, because this is just our comment here. Back down here, we're back into code. So like I said, quick little example of how you might want to use more than one quotation. Most of the time, you just use either or, it doesn't matter. Every once in a while, you got a case where you got that. Okay, so we're going to say object is cube. Let's get the system console up here. Whoops. Okay, I got that handy. I'll pull that in a second. Okay, so let's run this now. This should work, I believe. Yeah, so that deletes our object. And what does it say in our console? It says cube deleted. So let's undo this. And what if we do bpy.data.object is the camera? And then let's run this. So it did select the object, but it didn't delete it because, and it says that's no cube. So let's look at this now. We've called it delete. You know what? Let's give it a better name. Let's call it delete cube. Down here, we'll call it delete cube. And let's try and run it again. Same result. Okay, so I'll click the light, selects the camera every time. And what happens? I ran it 3 times. That's no cube, that's no cube, that's no cube. Okay, so we've got this delete cube function. It takes an object. And then inside this, first thing we're going to do is we're going to select that object. And then if the object's called cube, so I think we talked about the equals. I'll have to look back in the video now to see if I actually talked about 1 equals versus 2 equals. If not, that'll be coming up next. So if you don't come from a programming background, you're probably seeing this and you're going like, oh yeah, that's the equal sign. So object equals bpy.context, but that's not what's happening here. So 1 equals sign is the assignment operator. So the way I think about it in my head is 1 equals sign, 1 equals sign is the equivalent of is, the word is. And I know is a reserved keyword in Python, but we're not going to dive into that right now. When you put a single equals, you are saying this thing is that thing. Not their, 2 plus 2 is equal to 4. You're saying 2 plus 2 is 4, which of course, 2 plus 2 is 2 plus 2. They both add up to the same thing, but a single equals in programming doesn't mean that, or a single equals in this context, I should say. 2 equals means equals. But if the object's name is equal to cube, then delete that object and print cube deleted. Or else, if the object's name is not equal to cube, then print that's no cube. So then we define the object down here. We say the object is bpy.data.objects.camera. It says, okay, delete the cube. The object is equal to the object. We run through here. It says, okay, I'm going to select the camera. Okay, and then I get here. If the object's name is equal to cube, well, the object's name is camera, so that's not equal to cube. So it's just not going to do any of the stuff that's indented on this line. Instead, it's going to go down to the same level of indentation, and it's going to check here. So it's going to say, or else, if, so that's, I can't remember if I can do an else if, or if it's supposed to be elif. Oh, I guess I can else if. Let's see if that works. No. Yeah, it didn't like that. So we do an elif. And it likes that. Nice. Okay, so or else if not the object's name equal to cube. So this is one of those, it kind of, when I say it out loud, it feels a little backwards. Sometimes I'm tempted to write else if object.name not equal to cube, but this is the context that it's looking for. So let's see if we take this here, elif not, we get an error message. We do it other way around, it works. So it's a little bit of Yoda talk. Like I said, if you're trying to do the, just read your code out loud as though it were a sentence. But this is the proper context for saying, or else if it's not that thing that it is, do this other thing. So that is a function, and that is passing an argument or an object into the function to have the stuff performed on it. That's also setting up logic inside our function to say, okay, we want to do it, if this or else if not that. And in the spirit of pointing out all those super common ones, another common line that you'll see is if bpy.context.object is not none. And that just means if we have, make sure that we have a selection before we do whatever, we're telling the code to do to the selection. Okay, and we'll talk just very briefly about naming conventions in Python. Because when you read the Python docs, they want you to, here, I'll pop this open. So this line right here is where 80 characters are. So let's just type in some random nonsense. So that right there is the longest that Python wants you to have a line. So Blender thinks that is a little restrictive. It's maybe a little bit short. So they extend that to, I believe it's 120, So if you take the two things that we know about Python, that it depends on indentation, and you combine that with the fact that they're recommending you have 80 character lines, like, how do you deal with these commands that are, when you do like a resize command? How do you deal with something that is this long? I showed you the indentation and different ways that you can break stuff down. We've looked at convenience variables, and that is going to be kind of what this little section is about. I'm going to try not to make this rant, because I do understand why this happens, but Python recommends that you name your variables, that you have your code easy to read. So they always say, 80 character lines, but if that makes your code incomprehensible, then maybe that's not the most important thing. Maybe the most important thing is keeping your code readable. For me, the most readable thing is a clear literal variable name. So if I look at a variable and it's called object material color, then I kind of know what I'm getting into. If I look at something and I see OMC, it's not necessarily as illustrative. It doesn't necessarily immediately tell you what you're dealing with. And one one example that I use to illustrate this is very often you will see, and I mentioned this once before, 1, 2, 3 letter variable names. It's extremely convenient as a coder, and I find it becomes a little bit nightmarish as someone who has to read code. Particularly in a program like Blender, particularly if you're not someone who specializes in, like you only work in Grease Pencil, you only work in the node editor, and that's it. If you're someone who works kind of all around the program, then all of a sudden these little abbreviations become a lot less helpful. So one that I've seen before, and I'm not going to, track down which add-on because it was something that I was learning from, was v.co. And this one stuck in my head for a really long time because I think after I had finished reading the add-on or reading the code on GitHub, I had kind of forgotten which one it was, and I'd been looking at probably add-ons that worked in a different area. And then I started thinking about this v.co, and I was going, okay, is that vertex.coordinate? Is that like a volume.color? Is that value.cosine? Is that video.codec? Is that view.collection? And I started going like, holy, that could be a whole ton of different things in this program because Blender does so much. And it was at that moment that I decided that I don't want to work with variables like this because I don't find this is remotely helpful as someone who has to read or understand or interpret code. It's super fast. It's great to, just type that one v dot whatever as you're writing that code as the coder, but it's just such a nightmare to return to that later on. So I will usually let big, long, literal variable names trump any tiny little things. And it's not like you can't, shrink this down. You could say, vert coord equals vertex dot coordinate. There's ways that you could make things like a slightly more manageable without going so far as to make it, basically just adding a layer of obscurity to the code. So that's my little rant about Python naming conventions. We'll just look at a couple more things and then we will wrap it up because this is probably a long and likely the most technically complex video that we've had in the series so far. So we looked at conditions, but what if you don't need to do something, if this or that? What if you just want, let's add a monkey. We got that monkey command. Okay, so we're just going to do size, location. Did anybody catch it? I deleted my comma. Okay, so size equals 2, location equals 0. There we go. We got our monkey. So let's say we don't need to know if this, then this. We got to create the monkey. We just want to have 8 monkeys.
I'll let the monkeys loose.
So we can say for I in range 8, add the monkeys.
If he says he'll let the monkeys loose, He will let the monkeys loose.
And then we look. There's that, there's that, there's that, there's that, there's that, there's that. So we have 8 monkeys here. So what did I do? How did I know this? This is a loop that we're creating up here. And how do loops work? Well, it's going to do this thing. So it's kind of like, you know, we could define a function and then have it run here. So let's maybe even do that. So let's take this out. We'll put it up here, and then we'll say this is a function called add monkey. And we don't need to pass any arguments. It just adds the monkey. So then we want add monkey, and we'll run that 8 times. And then we go. So we've got our loop here, and it says for I in range 8. So we already know, you know, from seeing the results that it does this 8 times. So you can probably kind of figure out what it means. But to go deeper, to go a little more in depth, for I, this is our like magic keyword. I don't have to make it I could make it banana sandwich. For banana sandwich in range 8, we still get that many Suzannes. So this is just like a keyword that we can use in this loop later. So we're saying for this, in this range, then we could say, you know, banana sandwich dot whatever. In this case, I was just making it I because, you know, like that thing that I told you not to do a second ago. I believe it would stand for iterator in this case, or it's the, you know, it's the thing that we're doing over and over again. And how many times are we doing this thing? Range lets us define, a range of numbers. And in this case, I put 8, so it did it 8 times. So that's a basic example of how to use a loop. And to look at a more advanced example, we'll get rid of all of these. We don't need it as that. The last 2 bits of Python data structure that we're going to look at today, which are dicts and lists. Flip those around, lists and dicts. We're going to look at lists first. So our list is equal to brackets. What does this mean? It is what it says it is, a list of whatever we need. So it could be a list of numbers, a list of strings, a list of anything. So I'm just going to make this list, the list of objects that we have. Let's get ourselves a cube back in there. List of objects that we have in the scene. So we're going to say cube and camera and light. So if we want to say, let's add the monkey. bpy.ops.primitive, bpy.ops.mesh.primitive monkey add. Okay, so we don't want to do it 8 times. We just want to do it as many times as there are entries in this list. So we just say for I in list. And let's see what happens. Oh, okay. Well, let's... Oh, I didn't indent it. Foolish, foolish me. Okay, here we go. Let's try it again. All right, I thought I could just put that in there. Let's make it a string. What to do wrong? All right, well, I did a bunch of things wrong there. But anyway, here we have a list, and it's a list of 3 items. And then we say for I in list, add the monkey. So actually, yeah, let's get rid of that, and let's add... How many monkeys? We got 1, 2, 3. So let's see what happens if we say Shazam... kapow, and blammo. Let's delete all those monkeys. And boom, now we've got Suzanne 1, 2, 2, 2. We've got 6. And sure enough, we've got 1, 2, 3, 4, 5, 6. So that is an example of how to create, how to use a list. Let's talk about that very last one. And that will be it, because this is a long one. Okay, so a dict is curly braces. And then inside a dict, you have keys and values. So whereas a list, it's just a list, you can read it, you can reference it, you can, add to or subtract from it. A dict is something, it works like a dictionary where, you know what the word is, you know what the key is that you have to put in, but you don't know what the definition is. You don't know what the value that you're getting back is. So it works with keys and values, and the key works like the word, and the value works like the definition. So anything that you plug into the dict, so let's say item 1, and then item 1 is banana sandwich. And then we go to item 2. And item 2 is a magnificent speedboat. Okay, then we can say, we'll get rid of this, print dict, and then item 1. I think that's how you structure it. So let's play. No error messages. Get our system console up here. I think I just hid it behind some windows. And prints banana sandwich. Very nice. So let's say we want item 2. Where is that? A magnificent speedboat. How wonderful. And, you don't need to name them item. You can name them really whatever you want them to be. So let's do that. And let's say that's equal to, how did you type in that string? And I'm going to cheat by copying and pasting it. Let's get that 2 out of there. Whoops. And hit play. And what does it say? It says, how did you type in that string? So basically, this is a way that we can link to different variables, different... it's a way that you can put one thing in and get a different thing out. So for a really basic example, I created a dictionary for another add-on that did voice recognition. So I would speak the words, the voice recognition would type it into text, and then I would use that text as a key to look something up in the dictionary. And in the dictionary, I looked up an operator. So whenever I said the word delete or delete object, it would, look up the words delete object, and it would use that as the key, and it would return the value bpy.ops.object.delete, and then perform that function. So just a very simple example of how you can use a dict. So there are other data structures in Python. There's, a whole ton more to Python than I've ever talked about or shown you, but that is probably the deepest we're going to go, really. You're going to know how to run things in a loop. You're going to know how to set up conditions so that things only run under the conditions that you want them to. So if you have a selection, this happens. If you don't have a selection, it'll return that message like, oh, you need to make a selection, or something like that. So you can kind of control how the flow goes. You know about indentation. You know about creating different data structures that you can use. And then we've got one more kind of getting started, where we look at how to structure UI. And because we've talked a lot about functions. We haven't really talked about, like most add-ons come with a little panel with buttons and stuff you can press, and it's got all that kind of stuff. So how do you link up the things that we've been doing so far where we're just writing code to that thing where you can actually see something in the, in Blender and press the button and get it to do what you want it to do? So that one's going to come up next. And then after that, I think we're going to be looking more at the, the actual coding, and we'll get into some example add-ons, because I've got a few ideas for something that's relatively simple, but it'll still get your feet wet with, all the different areas that you have to get through. So we'll see you next time for UI stuff. Bye.